Hello everyone, I am Karan Malhotra, a graduate student at the University of Illinois Chicago, and in this video I'll be demonstrating how to execute and deploy map-reduce models for parallel distributed processing of large big data sets of log. So this is my README file where I have mentioned the development environment which I have used and the two deployment environments which are the Hortonworks HTTP sandbox and the AWS Elastic Map Reduce. I have also mentioned a detailed steps to run the application, and I'll be demonstrating these steps in the video as well. These are the few test cases I've written to confirm if the map reduce models will be executed successfully. So it is essential that you run these test cases before you create the jar file. There are four jobs written in this project, four map reduce jobs, and these are the descriptions of what each job does. And for this job, I used Dr. Mark's log file generator project, which generates log files. And I made few tweaks in the configurations, which I have mentioned over here. I increased the max count to 1000, so the total number of lines generated by the log were 1000. And I increased the frequency of error logs to 0 to 0.25 to get better results and to validate if the map reduce model that I was working on worked as expected or not. I have also uploaded a few screenshots of the project. So we'll start with the test cases right now. So this is the current working directory where where the source code is there. SPT test will execute the 8 test cases that I have written. We wait for them to execute. It is executing right now, and in a few minutes, I think, not few minutes, I think few seconds would do. Let's see. And yeah, so as I can highlight on the screen, 8 test cases were executed and 8 of them passed. So I think we are good enough to create the jar. So for that, I'll type svt clean compile assembly. This will start the creation of jar. So the jar creation would take around 2 to 2.5 minutes on my system. So meanwhile, what we can do is we can set up the Hortonworks HTTP sandbox. So I'll open git bash while this is executing. I'll SSH to my VM, enter the password. As you can see, I have logged into the VM. I've already created a folder over here called log processing. The folder has the big data log. I'll actually delete the log to show how I can transfer the logs via SCP. Okay, but meanwhile, I'll open the README and yeah, I have to create a Hadoop storage file. So I use this command to create that. And a HDFS storage file has been created. And now, yeah, I have to SCP the big data log file from my local to my VM. So I'll open another PowerShell for it. Okay. So for reference, I have already uh, put the big data log file in the resources directory. So I'll cd to that directory right now. Here I am. And this is the scp command to send the big data log file from my local machine to my VM. It will ask for my password as expected. Once I've entered the password, I'll just verify whether I have received the file, and I have received the file. Yeah, so now we can send the files to the Hadoop storage by using this command. And once it is done, we'll validate as well. So for validating, I'll just ls the Hadoop storage, and I expect to see the big data log file inside. Not sure why it is taking so much time. Okay, yeah. So as this is done, I'll just check. Okay, so the build should be done soon enough as well, I believe. And once the build is done, I'll SCP the build to the VM and then execute one of the job and display the output for it. After which I'll also display an output and steps to actually deploy on Amazon EMR. If I believe the video is taking too long, I'll actually pause the video for some time so that the video recording doesn't become too long. I think I'll pause it right now. Okay, so I think the jar should be created very soon. Okay, so it has been created and the jar would be located in the target slash scala hyphen 3.0.2 directory. Yeah, so this is the jar file that I have to SCP. I already have the command for it. Yep, so I'll SCP, I'll enter my password, and yep, so the jar file has been sent to my VM. I'll just confirm. Yeah. So I'll actually execute the first task and show you how the output is created. The output would be a comma separated value, CSV. So the command to execute would be Hadoop space jar, then the jar file, then the input file from the HDFS storage, which is big data log.log, and then where we prefer to have the output stored, which is output 1. Okay, I actually missed this. So the first argument has to be the task number that we want to be executed. So 1 if we want the first task, 2 for the second, 3 for the third, and 4th for the fourth one. So now the first map reduce job will be executed. I don't believe it should take a lot of time. So we'll actually wait. And while this is done, I'll actually show the executor as well. Yeah. So I have a map reduce executor and different map reduce jobs. So over here, as you can see, if there's for zeroth argument is 1, then the first map reduce job is executed, 2, the second one, and so on. We have also set the configuration to allow the separator to be a comma to get a CSV like file. And here we have the two different files for the test cases. Oh, so the map reduce job has started executing. I've set the reducer to be only 1, so it will be easier for me to display the output in the video, but through the configurations in application.conf, you can increase the number of reducers as you like. Having more reducers would help with more parallel distributing of the task. Okay, so the map reduce has been completed successfully. I'll see if the output directory is created. dfs -ls hadoop underscore storage. So we do see a success and a output file over here. I'll print the content of the file. And as you can see, you get an output of comma separated values through the execution of the first map reduce job. I'll actually also show the second map reduce job over here. So the second map reduce job I have written actually has two map reduce jobs inside it, and the output of the first reducer would be the input to the second mapper. So 2 for the map reduce job 2 to execute the input, and then I'll have an intermediate storage file followed by the output 2, which stores the final output. So through the CLI, we will actually see how two map reduce jobs are getting executed one after the other. So I think, yeah, so now the first map reduce will be executed. I think it is probably taking some time to execute because of the screen recording, but I'm not sure. Usually it doesn't take that much time to execute. Yeah, so the first map reduce job got executed, and now the second one has begun, which you can see over here, the highlighted text. Once this is executed, we'll see the contents of the second MapReduce job, and after that, we'll go to AWS. Yep. So the job 2 has been executed successfully. Here we'll get the final output of the job 2. This would have the output in a descending order of the counts of error found in that particular timestamp as expected. Yep. So let's now proceed to Amazon. So this is the AWS management console. This is my user ID and my account information. Let's see if the organization would show anything. No. So I'll show the billing as well. So I'm being charged for what I execute. So I'll just execute one job over here to show how to execute. So I'll go to the simple storage service and I'll upload my jar over here and also the log file. I already have the bucket created for me. So over here, documents, code, target, Scala. Yep, this is my jar file. I'll upload. This would take a few seconds to upload. It's a big file. After this, in the input directory, we'll upload the big data log.log file, which is present in the resources directory of the source code. The upload is almost done. Close, input, upload, and file. Resources, big data log.log file. This should be very quick as expected. Now I'll go to the EMR and I'll create a cluster over here called my cluster. It's okay. This is where the logs would be stored for the EMR execution. The instance type would be M5 extra large. Go to the advanced options. We just need Hadoop. We'll try to minimize as much as we can. The cluster should auto terminate so I'm not charged extra. And I give the path for my custom jar over here, which is this one. Select. And as an argument, I pass the third MapReduce job I want to execute. The input file would be this one. And I want the output file to be on the S3 bucket as well. The folder should be called output 3, and action on failure should be terminate cluster. Add. We'll click on next. As mentioned earlier, we already know the instance type and we are okay with it. We'll click on next. We are already aware of the login. We'll click on next. We're not going to SSH into the EMR instances, so we don't need to have key pairs for it. We'll create the cluster directly. So this execution would take a lot of time. Hence why we always mention why the elasticity is not actually that elastic. So the provisioning will take some time. The logs would be generated over here. I'll pause the video for now and start again when we have something concrete to show over here. So the instances are now running. The logs haven't been generated yet. I think once the execution is done, we'll be able to see some logs. This, I believe, shouldn't take a lot of time based on my previous executions. So we'll just hang around. Monitoring, we'll see if monitoring shows anything decent. I think the execution time should be quite a lot if you want to see something concrete in our monitoring. Yeah. The map reduce is being executed right now. No logs yet. We'll browse through all the other options and see what we can understand right now. These are all basic configurations set to execute the EMR. So the map reduce has been completed and the instances are now terminating. We'll see if any logs have been generated now. Yep. Yeah, so as you can see, the map reduce job was completed successfully. We'll go to the bucket and see the output over there. Log processing map output 3 has been created and it has one part, only one, because I've mentioned that I only require one reducer for this map reduce. I'll download this and we'll see if the output is what we expected it to be. Yep, so the output is the count of these log types within the log file that I have sent as an input. We already saw that there were 1003 lines, and I think if you add it up, you'll get 1003 as well. So This would also be a cross check to see if a map reduce is working correctly or not. So this is it for the video. Thank you and have a good one. Bye bye.